Hey guys, and welcome back. My name is Miss Danielson, and I'm here with another algebra lesson for you today. If you joined us for our previous lessons on solving linear equations and solving two-sided equations, you should be ready for this lesson on setting up and solving these equations from word problems. So I'm going to link those lessons down in the description box below for you in case you haven't seen them. But if you have, let's go ahead and get started with some examples. I think of a number and add 7, then I multiply the answer by 4, and the result is 20. These word problems can get very wordy and difficult to figure out, so it's always a good idea to write down a couple of notes as you go through. If we want to write an equation for this question, first think about what we don't know here. Let's start by identifying the variable, so the letter, that we're going to use to represent this unknown number. I'm going to let x represent the number I first thought of. And so if we consider that the number I'm thinking of is x, this word problem tells me exactly what to do to x. I need to add 7 and then multiply that answer by 4. In order to make sure that we're going to add before we multiply by 4, let's put that in brackets. And a number in front of a set of brackets is going to multiply by the result of what's inside that bracket. Next, what were we told that this equation was equal to? I think of a number, add 7, and multiply the answer by 4, and the result is 20. That's what makes this an equation. I know what it's equal to. Next, let's solve this equation to find out what number I started it off with. To solve an equation, remember we need to think about what's happening to the variable, or the letter that we don't know the value of, and we need to undo those operations in reverse BEDMAS order. So looking at my equation here, the first thing that's happening to my x is what's happening inside this bracket. It's adding with the 7. The next thing that's happening is this answer is getting multiplied by 4. So if we go backwards through that, the opposite of multiply by 4 is divide by 4. That leaves me with just x plus 7, and the 4 has moved from the left-hand side over to the right-hand side, and we're dividing the 20, which was already there, by 4. Remember, the order is important. It's 20 divided by 4, not 4 divided by 20, because the 20 was there first. So x plus 7 must be equal to 5 then, but we want to know what the value of x is. So let's get rid of that 7. The opposite of adding 7 is subtracting 7. So by subtracting 7, the 7 is no longer on the left-hand side. I have to do the same thing to the right-hand side, so I've just subtracted 7 from there, and x must therefore be equal to -2. So that's my answer, but I can always check my answers with these equations. I know that if I have the correct x value, then 4 times the answer of that x value plus 7 must equal to 20. Let's try that and see. If x is equal to -2, does that mean that 4 times, in brackets, x's value, which is -2 plus 7, will that make 20? I'll work out what's inside these brackets first. -2 plus 7, you should remember by integer addition, is the same thing as 7 minus 2. That's going to be 5, so 4, and then in brackets here I have 5. Is that equal to 20? Remember, a number in front of a bracket is simply multiplying by what's inside that bracket, so 4 times 5, that is 20. So yes, our answer is correct. X is equal to -2. There is another method that you could use to solve this equation. As I've shown before in previous lessons, you might first look at this expression and say, oof, I think I could probably simplify that before I try and solve it. And by simplifying, what I mean is a number in front of the bracket multiplies by every term which is inside the bracket. So I'll do 4 times the x and 4 times the 7. That's called expanding the brackets out. And again, if you've seen our previous lesson on expanding brackets, you should already know how to do that. Now that this is as simplified as it can be, let's try and get that x on its own. Think about what's happening to the x. It's being multiplied by 4, and then the 28 is added. So going backwards, let's get rid of that plus 28. Opposite of plus 28, well, minus 28. And now to get that x on its own, let's get rid of the 4. Remember, a number in front of a letter means multiplication, so the opposite of multiplying by 4 will divide by 4. That'll leave the x on its own. And on the other side of the equation here, we had -8. So make sure you have the correct order. That's -8 divided by 4, not 4 divided by -8. -8 divided by 4, 8 divided by 4 is 2, so -8 divided by -4 is -2. Notice we did that in a slightly different way. However, we did follow correct order of operations and we do get the same answer. X is definitely -2. And sometimes it's good to have more than one method to solve an equation, because if you do it both ways and get the same answer, you've most likely got it right. But don't forget, you could also do the check. This next example is a bit more of a real-world example. I put the same number of chocolates in each box. How many chocolates did I put in each box? If I started with 209 chocolates and I filled 12 boxes and have 5 chocolates left over. Well, that was very wordy. Let's first think about what information was given. I'm told about some number of chocolates. There are 12 full boxes of chocolates and 5 extra chocolates. What was this information equal to? Let's read that question again. I put the same number of chocolates in each box. How many chocolates did I put in each box if I started out with 209 chocolates? So these 12 full boxes plus the 5 extra chocolates must add up to the 209 chocolates I started with. But again, there's some unknown value here. I don't know how many chocolates are in each box. So let's write a let statement to identify the variable that I'm going to use to represent this unknown number. It's generally best to pick a letter that you'll remember in the future. I'm going to let B represent the number of chocolates in a box. Make sure your let statement is a nice full sentence here. B is not the number of boxes or the size of each box or the weight of each box. I've clearly stated that B is the number of chocolates in each box. So I'll rewrite my equation then. Let's write this algebraically. That's 12 times B, that's 12 times the number of chocolates in each box, plus 5, because 5 is simply a number of chocolates. And that's equal to 209 chocolates altogether. So now that we have an equation, reread the question to see what it is we're asked to find. How many chocolates did I put in each box? So I'm trying to work out B. Think what's happening to B. It's being multiplied by 12, and the 5 is added to it. Let's undo that. So the opposite of adding 5 will subtract 5. 209 minus the 5 will be 204, but I still have 12b is equal to 204. I need the b on its own. Remember, a number in front of a variable is multiplying, so the opposite of multiplying, we will divide by 12. 204 divided by 12 is 17. So there must be 17 chocolates in each box. Let's do the check to make sure we've got that right, though. So if b is equal to 17, that means if I put the value 17 instead of the b, so 12 17s plus 5 equals 209. Note that I always substitute a value into an equation by putting it in brackets. So I didn't write 1217. So multiplying that through, 12 times 17 is 204. And 204 plus 5, is that 209? Yes, it is. So we've got our answer correct. And don't get it confused, our answer is not 209. The total number of chocolates I started with was given in the question. That's 209. All I found is the number of chocolates I have put in each box, which is 17. Let's go on to a two-sided equation now. I think of a number and I divide it by 2. Then I add 1, and the result is not a number. Be careful here. The result is the same as if I doubled the number and subtracted 2 from the result. So this time, to set up our equation, we need to think of the given information. What is the information given? I'm not told that some calculation is equal to some number. I'm told 2 sets of calculations. And what is this information equal to? They are equal to each other. So I'm going to set up an expression here, a set of calculations with some unknown variable and some numbers, which is equal to another expression. So a set of calculations with that same unknown variable. Let's start by identifying the unknown number. In both of these calculations, I'm starting out with the number that I'm thinking of. And I'm performing a few calculations to it, and the result is the same if I had taken that same number and doubled it and subtracted it. So the unknown number is the number I'm starting with in both cases. Let's make a let statement to identify the letter or variable we're going to use to represent that unknown number. So let x represent the number I first thought of. In the first set of calculations, I was told that if I divide x by 2 and then add 1 to that result, the answer will be the same as this next set of calculations. I double the number, so 2 times that unknown number, and I subtract 2 from the result. There's my equation. But it's a two-sided equation because I've got an unknown variable on both sides of the equal sign. I've got an x here and an x there. So let's try and rearrange this equation to solve it to find out what x is. To solve a two-sided equation, what you need to do is get all of the variable terms to the same side of the equation and send all the number terms to the opposite side of the equation. If you joined us for our lesson on solving two-sided equations, you'll remember the rule is to generally try to move the smaller of the variable terms. The variable terms are the terms that involve a letter. So here I've got 2x, and here I've got x over 2, so half of x. I hope it's fairly clear which of these variable terms is smaller, 2x's or half of an x. Hopefully you're saying half of an x. So I'm going to move this term over to the right-hand side. Right now, this term is being added to the one, so the opposite of adding, we're going to subtract it. So we're going to take the x over 2 to the other side and minus it. And in the same step, I'm trying to get my number terms over to the left-hand side. So this minus 2 here, the opposite of subtracting 2, I'll plus it to the other side. My minus 2 is now over here plussed, and my x over 2 is over here now minused. Now let's simplify this a bit. 1 plus 2, that's easy, is 3. And 2x minus half of x, maybe it's easier if I turn that into a decimal for you. 2x minus 0.5x, they're like terms. There's some number of the same variable letter. So how many x's is that? 2 x's, take away half an x, that's going to be 1.5 x's. So we've got 3 is equal to 1.5x. I want to know what x on its own is though. So I need to get rid of the 1.5 that's in front of the x. Remember, a number in front of a variable is multiplying, so the opposite of multiply will do divide by 1.5. 3 divided by 1.5, I hope you recognize that is 2. It takes two 1.5s to make up 3. So x is equal to 2. Now I definitely want to do a check here because that was quite a difficult solve. So let's go ahead and substitute that back into the original equation to check if x is actually 2. If x is equal to 2, does that mean that 2 divided by 2 plus 1 is equal to 2 times 2 minus 2? Let's work this through. 2 divided by 2, that would be 1 plus 1. And 2 times 2, that would be 4 minus 2. Is that going to work out? 1 plus 1 is 2, and 4 minus 2 is also 2. So the equation is equal. X must be equal to 2 because that's the value that makes this set of calculations equal to this set of calculations. So there's our answer, x equals 2. Here's one last two-sided equation as an example before we do our practice exercise. I sold 3 full boxes of cookies and an extra 8 cookies. My sister nearly sold 7 boxes of cookies, but she had 4 left over. Work out the number of cookies in a box if my sister sold twice as many cookies as me. Again, this word problem is quite wordy, so let's think about what information was given. I'm told how many cookies I sold and how many cookies my sister sold, but they are not equal. My sister sold twice as many cookies as me. So don't make the mistake of simply saying the number of cookies I sold was equal to the number of cookies my sister sold. It would take 2 times the amount of cookies I sold to be equal to the amount of cookies my sister sold. Now, it's very common when people see twice as many in a question, they accidentally double the wrong value. I don't need to double the cookies that my sister sold to make them equal to mine. The number of cookies my sister sold is already 2 times the amount of cookies I sold. So now that we have an idea of how many cookies we're comparing in this equation, let's write a let statement to identify the values we don't know. I sold 3 full boxes of cookies and 8 extra cookies. Okay, the 8 extra cookies is clear, that's 8 cookies, but how many cookies is 3 full boxes of cookies? The unknown value is the number of cookies in each box. So I've used the letter B to represent the number of cookies in each box, not the size of the box, not how many boxes, not how much the box weighs, not the color of the boxes. I'm making my let statement very clear. It's the number of cookies in a box. So if I sold 3 boxes of cookies and an extra 8 cookies, and my sister sold 7 boxes of cookies, but had 4 cookies left over that she did not sell, and the amount that my sister sold is 2 times the amount that I sold, so twice the amount that I sold. That's our equation. Let's go ahead and solve this. Before I go moving things around, however, let's try and simplify the expressions on both sides of the equation. So here, I've got 2, and then I've got a bracket. Let's expand out that bracket. So I'll do 2 times the 3b, which is 6b, and 2 times the 8, which is 16. So 6b plus 16 is equal to 7b minus 4. Now let's get our b's together. Which of the b terms is the smaller b term? 6b's or 7b's? I hope you're agreeing with me that 6b must be smaller than 7b. So let's take the 6b over to this side, and we'll take the minus 4 over to the left side. So variables on the right, numbers on the left. The 6b is adding with the 16, so we'll minus it. And the 4 is clearly minusing, so we'll add it. So I've got 16 plus the 4, and I've got 7b minus the 6b. Let's simplify that. 16 plus the 4 is 20, and 7b minus 6b. How many b's is that? That's 7b's, take away 6b's is 1b. 1b is the same thing as just a b on its own, and b on its own is equal to 20. Again, remember what the b represents. B is the number of cookies in a box, and that's what we were trying to work out the number of cookies in each box. There are 20 cookies in each box. Shall we check it? If b is equal to 20, we should be able to do 2 times 3 times 20 plus 8, and that should be equal to 7 times 20 minus 4. Are they equal? Using BEDMAS order of operations, first thing we do is what's inside the bracket. I see 3 times 20 plus 8. We'll do the multiplication first. So that's 60. Plus the 8 is 68. On the other side, I had 7 times 20 was 140. And then minus the 4, that's 136. I still have to do 2 times 68. Please tell me 2 times 68 is 136, is it? Yes, it is. So I must have sold these 68 cookies, and my sister, who sold twice as much, sold 136. But I've got an equal equation here showing that my sister's 136 cookies is 2 times my 68 cookies. So we've got a balanced equation which shows we have the correct B value. The number of cookies in a box was 20. Now, how was that? I'm sure you're finding these questions a bit wordy, but I'm hoping that you're ready to try and give it some practice on your own. Question 1, I think of a number. You can use any letter you like to represent that number. Then I double it and subtract 8. What was the number I was thinking of if my answer is 6? So something's equal to 6 here. Set up an equation and solve it. Question 2, I think of a number, so any letter you like, subtract 8 from that, and then double the result. You may want to use brackets here. What number was I thinking of if my answer was 6? Question 3, I think of a number, any letter you like, half it, and add 7. The answer is the same as if I added 2 and then triple the answer. What was the number I was thinking of? This time it's going to be a two-sided equation because you've got two sets of calculations which are equal to each other. Be very careful when you're setting up this equation, and then remember to do your check to make sure you've rearranged and solved correctly. Question 4, I think of a number, any letter you like, add 7, and then half the result. The answer is the same as if I times the number by 4 and subtract 3. What number was I thinking of? Again, this is a two-sided equation because we've got two sets of calculations which are to be set equal to each other. So set that up carefully and don't forget to do your check. Question 5, a more applied question this time. Two boys have the same age. Think about that before you even start. They have the same age, equal ages. One of them is 3 less than twice my age. Ooh, my age, where does that come in? The other is 7 older than me. How old am I? So again, you've got a two-sided equation here, and there's some unknown information. I don't know how old either of the boys are, but I know they're equal to each other. But the other thing I don't know is how old am I? Go ahead and choose your variable carefully, set up that equation, solve it, and don't forget your check. Question 6. Two customers at a pizza truck both pay the same amount. Same amount. Again, I'm thinking if they're the same, something's equal here. One bought 5 slices of pizza and left a 50-cent tip. The other bought 4 slices of pizza and left a €2 tip. That was generous. How much does each pizza cost? Okay, have you figured out what the unknown information is? Go ahead and set up a let statement for some letter to represent that unknown value. We know this is a two-sided equation, two sets of calculations, and we are told that they are the same amount, they are equal to each other. So, if you're ready, go ahead and hit pause. Make sure you copy the question. I know they're long and wordy, but if you've written the wrong equation and you don't have the word problem that they've come from, you won't know where you've gone wrong. So take your time with that. Show you're working. Check your answers wherever possible, and push play when you're ready to take it up. I hope you had a chance to hit pause, because here come your answers. For question 1, and my answer should be 7. For question 2, I subtracted 8 from my number, and then I double the result, so I hope you used brackets. First, I expanded out my brackets, then the opposite of subtract 16 will add. The opposite of multiply by 2 will divide. Or you might have worked it through another way. The opposite of doubling, divide by 2. Then the opposite of subtracting 8 will add 8. But either way, you get the same answer. 22 divided by 2 is the same thing as 3 plus 8, and in both cases, it's 11. Question 3, those two calculations are equal to each other. In the second calculation, I hope you used brackets because we're adding the 2 first and then tripling, so that's timesing by 3, the answer. To solve this, first let me expand out the brackets, then let's get the x terms together. Simplifying that, grouping like terms, 3x minus half of x is 2.5x. Opposite of multiplying by 2.5 is dividing by 2.5, which might be a difficult calculation for you to do. If you've just used your calculator for it, that's fine, but please try and understand the mental working that goes behind it. you could have thought of 2.5 as being a fraction. So this is 1 divided by the fraction 5 over 2. Half of 5 is 2.5. Then you should remember that to divide by a fraction, we cross multiply. As we flip the fraction over and we multiply. 1 times 2/5. Well, 1 times any value, the value is not going to change. So x must be equal to either 2/5, or if you know it as a decimal, that's 0.4. Either answer is fine. And I would imagine that if you just use the calculator here, you probably gave the decimal answer. For question 4, I set my two calculations equal to each other. And here we've got a fraction. But the easiest way to think of a fraction is just to think of it as a division. So the opposite of dividing by 2, I'll take it to the other side and multiply by 2. No more fraction to worry about. Now let's expand out that bracket before we get our x terms together. So multiplying that through, simplifying that, opposite of multiply by 7, divide by 7, and that's top heavy. If you just used a calculator to work it out, you've got a very long decimal number. So let's try and work this out as a mixed number. How many 7s are there in 13? Well, 2 7s is 14, so it's not 2, it's just 1. And how much would be left over? 13 is 6 more than 7, so that's 1 whole and 6 sevenths. Or as I said, if you just use the calculator, you got a very long decimal number, which would round to 1.86, to 3 significant figures, or 2 decimal places. For question 5, the unknown variable, how old am I? Let x be my age. And the calculations related to my age of the two boys' ages are equal to each other. Let's rearrange that, getting our x's together. 2 minus the x term. And on the right-hand side, the 3 is coming across, so I've got 7 plus 3. Simplifying that, so x must be equal to 7 plus 3, which is 10. I must be 10 years old. I hope you double-checked your answers. How old are the boys? 2 times 10 is 20 minus 3 is 17. Or 10 plus 7 is 17. Both boys are 17 years old. Question 6. Let P be the price of 1 slice of pizza. And 5 slices of pizza plus the 50-cent tip is the same amount as 4 slices of pizza and a €2 tip. Let's get our P terms together. Simplifying that, try to remember what this variable represents. P is the price of a slice of pizza. It's not the number of pizzas. It's not the weight of a pizza. It's a price in euros. So let's make sure we give our answer in the correct format. P is equal to €1 and 50 cents. We always give money to 2 decimal places, not to confuse this with €1 and 5 cents. Now, how did that go? This tends to be a difficult topic, which requires a lot of practice. So if you had any difficulties, please leave me a comment down in the comment section. Otherwise, have a careful look over it. Make sure you've copied everything out so that you can come back and revise from it often. And until next time, keep practicing, and I'll see you soon.